Brand new unit. This next unit is called thermochemistry. Thermochemistry, just to kind of dissect that word a little bit, thermo means heat, so using or relating to heat. Chemistry is the study of matter and the changes that matter undergoes. So what we're going to do in this unit is we're going to look at heat transfers when it comes to chemistry. And when we look at heat transfer when it comes to chemistry, we're going to look at heat just in general and how heat travels, how heat transfers. It should be a little bit of a review from your previous science courses. Then we're going to talk about heat in chemical reactions. And finally, we're going to look at heat in terms of solution making. So we're going to look at heat in several different capacities in this unit. It's about half math, half vocabulary, so kind of like the solutions unit that we're kind of half and half again. But we're going to get some vocabulary out of the way first today. So as we look at this next unit, like I said, we need to define some words. And the words that we're going to define, we're going to start off with the word just energy. And the word energy means that you have the ability to do work or to produce heat. Doing work, it's kind of a physics definition there, but basically it means to move something is kind of the general term with that one. If you're a physics person, I'm sorry. If you're watching that you're not in my class, I'm trying to bring it down to their level. You'll learn a lot more about work in physics next year, but it's basically being able to move something for this class. The other capacity that we have is to produce heat. We're going to learn that heat and temperature are actually two different things, so we'll kind of look at that definition as well. Now there are two basic forms of energy that we're going to look at in this class. When we look at these two basic things, we're going to, like I said, give a very broad definition of them. And as you get into physics, you're going to get a lot better definition of potential energy and of kinetic energy, because there's different types of potential energy, things like that, that we don't care about for this class, to be totally honest with you. We're only going to look at potential energy and we're going to look at kinetic energy. So the first one, your kinetic energy, is a study of energy of motion. So when things are moving, they have kinetic energy. All matter, for chemistry, across the world, no matter what, all matter has energy. That's because their particles are constantly in motion. As long as you're above 0 Kelvin. Once you hit 0 Kelvin, those particles are no longer in motion. So everything has kinetic energy in terms of our chemistry that we're going to look at. So kinetic energy, everything has it. It's the energy of motion. Because of all those little molecules and particles and everything are moving, everything has kinetic energy. Now potential energy is stored energy. Again, there's different types of potential energy. We're just going to look at a very broad definition. And we're going to look at stored energy. Where we store energy for this class is in chemical bonds. So before, I'm trying to think of which unit it was, we talked about the fact that your chemical bonds, like in between hydrogen and oxygen or whatever and water, you're going to store up energy. That's chemical potential energy. And we'll get, like I said, a little bit more into that in just a little bit. Now, the other thing that we need to define is we need to define the law of conservation of energy. Your law of conservation of energy sounds a lot like the law of conservation of mass and the law of conservation of matter. That we have energy cannot be created or destroyed. It merely transfers from one form to another. So whatever energy we currently have in our universe, that's all the energy we have. It's just constantly traveling from thing to thing, gets stored into bonds, it gets released again. So the energy that we have is all that we currently have, just like all the matter that we have is all the matter that we currently have. It just transfers from one form to another as it moves through the universe. Now, we're back to this potential energy again. And with your potential energy, it is just the energy that's stored in chemical bonds. So it takes energy to break chemical bonds, but then you also have energy that gets stored inside of them. So when we need to break a bond, we add energy to the system, And then once we add the energy to the system, there might be extra energy that gets released out into the environment, or maybe it took extra energy to break the bond that we have a little release of energy, but net gain, we're in the negative. That's where we get our endothermic and exothermic. So with your ethanol here, I'm going to do a demonstration with the ethanol itself, but you have this chemical potential energy that is getting stored in the bonds. That energy gets released and it goes out into the environment. Now this video, it talks about a word called heat. Heat and temperature are not the same thing. I'm actually going to watch this with you guys because it is a good introduction into heat.
The mountains are icy, but they got motion of molecules. Ah! See, even cold things have heat. Things like snow and icy mountain lakes and glaciers, they've got heat. Anything with molecules has heat. It's just that the molecules in cold things are moving more slowly than the molecules in warm things. You with me? Okay, y'all ready? Sing along. It doesn't matter whether something feels or hot. If molecules are moving, it's something all together. You know what? Now sing along. It doesn't matter whether something feels or hot. Here's a question. Which has more heat energy? This hot burning match or this beautiful ice sculpture of science? Well, the match is hot, right? Sculpture's cold. Well, they're both made of molecules, right? But which has more molecules? The ice sculpture. A lot more molecules. So although they're much colder than the match, they actually have more heat energy. More molecules, more heat energy. Think of it this way. Suppose you try to take a burning match and use it to melt the whole ice sculpture. Well, it's not going to happen, right? I mean, the match is going to run out of molecules long before the sculpture. So, more molecules, more heat energy. Ooh, ow, ow. Careful. The swan.
Okay, so with your heat, it is an energy that flows from one object to another. Heat only flows from a warmer object to a cooler object. So I always tell the story in class about when I was growing up. My dad used to have this famous line, and it's a famous just dad line, that we would be standing in the doorway and it was really hot outside, and we'd be standing there with the door open. And when we were standing there with the front door open to the house, he would always say, "Hey, close the front door because," you ready for it? "You're letting all the cold air out." Now let's think about that. Heat only flows from hot to cold. So if heat only flows from hot to cold, my dad was wrong. You're not actually letting all the cold air out of the house. You're letting the hot air into the house instead. This is the same way that a refrigerator works. Another famous dad line, you'd be standing there with the refrigerator door open and he'd say, "Hey, close the refrigerator door. You're letting all the cold air out." You're not. You're actually letting the warm air in. And as you let all the warm air in, when you kind of go through that reverse process, thinking about the heat flowing only from hot to cold, you actually have to transfer that warmer air in your refrigerator. So you're not blowing cold air in, you're actually removing the hot air because it only flows from hot to cold. So as you start to think about that heat transfer through this unit, think about, okay, this is the warmer matter, whatever, and then this is the cooler one, so the heat can only flow from hot to cold. So you really need to think through that process, that heat will only flow from a warmer object to a cooler object. So when we get into things like exothermic and endothermic, we need to think about, okay, this is the actual stuff, the heat is flowing in or the heat is flowing out. So we really need to think about, the visual process of heat only flowing from hot to cold. Now, with the difference between heat and temperature, I did say that there is a difference there. Heat is measured in a unit called a joule, Joule. Temperature is measured in degrees Celsius or in Kelvin. Temperature is how fast or how slow those little particles are moving. Heat is the energy that flows from a warmer object to a cooler object. So they're not really the same thing. They're not measured in the same unit. So as we look through this unit, we need to think about that they are two different things. Yes, they are related, but they are not the same thing that we can use interchangeably with one another. Heat is an energy that flows. It is measured in a joule, Joule. Temperature is how much kinetic energy something has, how fast or how slow those little particles are going. Now, a thermometer is the thing that you use to measure the temperature, how much kinetic energy something has. So your thermometer is a device used. If we want to measure heat, we have to use a calorimeter or a bomb calorimeter. And we'll get into that in a few days, and we'll look to see what is a calorimeter, what is a bomb calorimeter. But you measure the temperature with a thermometer. You measure the heat with something called a calorimeter, and you actually have to derive it through a math problem. So you can only measure directly temperature. You have to follow the heat transfer. So thermochemistry finally is the name of this unit, and I kind of started with this, that thermochemistry is just the heat transfer, the heat that changes in a chemical reaction or in a phase change or in a solution. So it's actually, you can add solutions onto that because that is part of chemistry. But we're going to look at heat transfer throughout this unit. So we're going to look at just phase changes, then we're going to look at solution making, and then we're going to end up with your chemical reactions overall. This video I'm not going to show in the middle of this video just to keep mine shorter, but you're going to want to go back and watch this with your endothermic versus exothermic. So exothermic is the opposite of endothermic. Exo, exit. So think about that. Exo, exit. It's when heat exits from a system. It's going to feel warm to you because heat is leaving that source and it's transferring its energy to you. So the object itself is getting cooler. You are getting warmer. So it's kind of weird to think about if you have like an ice cube, or not an ice cube, sorry. I was talking about cooler. That was the first thing that jumped in my brain. If you have a fire, that fire as it reacts is creating all this extra energy. It feels warm to you because it's transferring its energy to you, but the fire itself is depleting. So the heat is exiting from the fire. It is transferring to you because you are absorbing all of its energy. Endothermic, heat enters into the system. So it's going to feel cold to you. So if I'm holding an ice cube, if I hold that ice cube, that energy from my body, from my hand, is leaving my hand and it's going into the ice cube. So it's going to feel cold to me because it is actually that the heat itself is leaving it. So if I'm the system, the heat is leaving, or I'm sorry, if the ice cube is the system, the heat is leaving me and it's entering into it. So it is actually getting warmer, which is why it melts. But I feel cold because it's stealing all of my energy. So again, we have to think about this heat transfer and how that heat flows from one place to another when we're thinking about endothermic and exothermic. So we're going to have to think about, what am I studying and where is that heat going? Is it going into or out of the system to figure out if it's endothermic or exothermic? That's actually as far as we needed to get today in the notes. We're going to talk about measuring heat in the next video, and then from there we're going to talk about calorimeters and some other things. So I hope that you guys have a great day. If you have any questions, make sure that you ask.